Hello, online learners. Digestion part 2. So before we actually continue on with part 2, which is the stomach and beyond, I want to show you one of my favorite videos on the digestion. Now, this video is a National Geographic, and it's interesting because they put animation, real tests, and real life videos together. So it's interesting, but it's also tricky to see what's real and what's animated. So pay attention to it. But I like it because the information is at the level you need to know at this course. So let's have a look at it. There we go.
She can take on more solid foods. Digestion starts in the mouth. Teeth grind up the food. Then special glands under the tongue pump out saliva to help break down and lubricate the food on its 12-hour, 13-foot journey through the gut. It'll pass from the stomach into the coils of the small intestine before finally passing into the large intestine.
So I'm sad that I don't have you there on purpose, because when the salivary glands squirt, there's always this ooh, and I missed the ooh. So did I get the ooh out of you? Also, here's a good example of how they take something that is, this image is probably a barium x-ray, but they've overlaid it with animation because your food doesn't go through that quickly. Your food takes about 12 to 24 hours to go through. You can test your own body system by eating corn, and I suggest you try it. So you eat corn and then watch, and because corn doesn't get digested well because we don't have the enzymes to break down cellulose. It's great for the body because you've got fiber, which acts as a little scrub brush to get the food through your intestine. So here's an example of how it looks and how you have all sorts of different types of images together.
Waves of contracting muscle keep the food moving, a process called peristalsis. These contractions are so powerful, we can even eat upside down. For the first time, a new camera shows a high-definition view of how food travels through our bodies and into our stomachs.
Okay, as we go through this video, I want you to pay attention to the lining of the intestine. So we started off in the mouth. You've got your it's nice and smooth, it's watery, and you also have your salivary amylase and your saliva coming out. Then you swallow, and you'll notice here this is esophagus because it's very smooth and very muscular looking. So pay attention to when it goes into the stomach. What do you see? Okay, see how the lining has changed, and it now kind of looks like a collapsed balloon. And these are what are called the rugae, and they're there to help expand the stomach when you put food into it.
Food enters the stomach through a hole at the top. The stomach is a bag of muscle that churns, squashes, and squeezes food into liquid. At the same time, acids break the food down. The stomach walls protect themselves with a lining of mucus. Without it, the acids could digest parts of the stomach itself, causing stomach ulcers. Okay, so let's look at the stomach itself
and the details on the stomach. So let's go back to the PowerPoint. With the stomach, what I want to, did you get grossed out too by that squirting? Oh, I miss you guys, just so I don't hear the oohs and ahs with that video. That's one of my favorite videos, my favorite digestion video. So let's look at the stomach itself here. So when you look at this part, there's a lot of terminology. I want you just to be, well, let's point out what you need to know. You need to know, first off, that the esophagus leads to the stomach. There's different areas of the stomach. I'm not too concerned about that, but what I do want you to realize is that there are sphincters at the top. The top one is called the lower esophageal sphincter, but it's also called the cardiac sphincter because it's the one closest to the heart. And at the bottom, the sphincter is called the pyloric sphincter. And so far, there's only one name for it. It's always the pyloric sphincter. So you saw in the video these rugae, or these folds. This allows, it allows for expansion when you put the food in. So I think you can go up to 2 liters. Anyway, from small to larger, so you want it to expand. Now, when we talked about the muscles and the layers of the intestine, you still have the mucosa, which is the inner part with the enzymes and the nice smooth surface. Then you've got the submucosa, which is where the nerves and the blood vessels are. And there's, again, the circular and longitudinal muscle. But in the stomach, there's the third layer of muscle, which goes oblique. So the longitudinal one goes up and down. The circular goes around. But the interesting thing is the oblique goes sideways. So this allows for extra churning, because the main mechanical function of the stomach is to close off those sphincters and just become a churning sac. And this will help break down the food. And then it is called chyme, with a CH, chyme, when it is in the stomach. So it is called a bolus as it comes down the esophagus, and once it gets into the stomach, the fluid mixture is called chyme. Now, the fluid mixture here has enzymes and it has stomach acid, and the reason why it's got the stomach acid and the enzymes has to do with the surface of the stomach. So when you look at the lining of the stomach, you see that there's these gastric pits. And in the gastric pits, there's 3 different types of cells. And each of these cells produce something different. So if we do the cross section, here's our mucosa, which is the top one, the submucosa, which has the blood vessels and the nerves in it. Then you've got the muscularis level with the 3 layers of muscle, and the serosa, which is the outside layer. When you look at the different layers in the pit of the stomach, the gastric pit, you have mucus cells which produce mucus. Now, mucus is very important because it helps to lubricate the cells, and it helps to keep the stomach with this lining, so that way the stomach itself doesn't get digested. When we talk about the digestion in the stomach, the main digestion in the stomach is of proteins, which is muscles. Now, the stomach is a protein, and you don't want to digest the thing that holds you, or you'll have problems in it. So that's one of the reasons you have mucosa, because mucosa adds this slimy layer which protects the stomach acid from digesting the stomach itself. There's also 2 other cells. There's parietal cells and chief cells, and both of those also produce enzymes. Now, to give you more detail, let's look at the textbook, because the textbook gives you a little more detail, and I want to look at the detail of the parietal cells and the chief cells. There we go. This is the one I want. Let me move it over if I can. Okay. So here in the stomach, you have your mucosal cells, which produce mucus. Then you have your parietal cells. Now, the parietal cells secrete hydrochloric acid. And that is important because it kills the microbes in the food, but it also changes the pH of the stomach acid. And that pH is very important to activate enzymes. And one of the main enzymes here come from the chief cells. So the chief cells release pepsinogen. And if you see this ogen lining at the end, ogen is a precursor. You don't want to release an enzyme that will eat your cell, so you produce or secrete an inactive form. So this is how pepsinogen is produced. Now, when pepsinogen gets into the acid part of the stomach, it turns into pepsin, and pepsin will now digest enzyme or digest protein. Then I just realized we've got a lot of secretions and hormones, and we should be summarizing those. So let's create a summary table. And we're going to call this summary table, second, I need to move it over here. So we're going to call this summary table digestive fluids, I guess is the best, because some are enzymes, some are hormones. And then we're going to insert a table, and we're going to have the name of it, the structure, and the acid, pretty much. Oops, I didn't go down. Just a second here. Good. So we're going to name it the fluid, location, action. Okay, so while we're summarizing, let's go back to saliva. Saliva. Saliva starts in the mouth, and the action of it is to lubricate, moisten, that's how you spell moisten, moisten. And then also there's salivary amylase. So I'm going to put it down underneath the saliva because the saliva contains salivary amylase. Now, amylase. That's, yeah, amylase. Now, anytime you see an ASE ending, that's an enzyme, and this still occurs in the mouth. And the function of the salivary amylase is to start carbohydrate. And I'm going to put starch in brackets because the main carbohydrate that you're breaking down in the mouth is starch. And you're going to start the carbohydrate digestion. And just a reminder that as carbohydrates break down, they will produce glucose or simple sugars. Okay, so there we have our mouth. Now, let's talk about our stomach. In the stomach, we have the fluid. First fluid is mucus. And mucus comes in the stomach, and it's from the mucosal cells. And that main function is to lubricate, but also to protect. Okay, to protect the stomach cells itself. So we have mucus. Then in the stomach, let me show you what we're looking at here. In the stomach, we have, so we're looking at the mucosal cells, then we're also looking at the parietal cells and the chief cells. So the chief cells produce the enzyme, and the parietal cells produce hydrochloric acid. Parietal cells. And then we have stomach chief cells. Okay, so out of the parietal cells comes hydrochloric acid. Notice it's a capital H, capital C, small l. And the function of hydrochloric acid is to, two things. One is to destroy pathogens or anything else that you don't want in the gut. And the second one is to activate the enzyme pepsinogen. Okay. Now, the chief cells is where the pepsinogen is created. And the pepsinogen will be activated by hydrochloric acid. So I'm just going to put here plus HCl to remind you that it needs to be activated. And that will become active pepsin. And that is the enzyme that starts protein digestion. Okay, so pepsinogen gets activated by hydrochloric acid to become pepsin, and pepsin breaks down proteins. Let's add a few more columns here because we're on a roll. Did you know that if you hit F4, it repeats the last function? Okay, save. Good. Okay, let's go back to the stomach and where we were at. So we were looking at the textbook. We talked about the mucosal cells, the mucus cells. I may have spelled that wrong. The mucus cells produce mucus. Now, if you're a spelling thing, notice that mucosa has a U in it and mucus doesn't have, sorry, has an O in it and mucus doesn't. I don't care if you can't spell them right. So, did we talk about protects it from being digested? Parietal cells, we talked about hydrochloric acid killing microbes. Chief cells secrete the enzymes pepsinogen, and the enteroendocrine cells. Entero meaning inside, endocrine meaning hormone cells. They produce ghrelin and gastrin. So ghrelin will stimulate the hypothalamus to increase appetite. And the way I think of that is your stomach will go grrr, make gurgling noise when you're hungry. So it will, your stomach will gurgle. And then gastrin, which will influence digestive function. And we'll look at gastrin a little later, but let's put it into our chart. So in our chart, we need ghrelin and gastrin. The spelling of that's tricky. Let me get it. I'm spellingly challenged. Is that a word? G-H-R, ghrelin. Can we do copy and paste? No. G-H-R, ghrelin, ghrelin, ghrelin. Ghrelin, and then we had gastrin. Okay, so ghrelin, gastrin. Is that spelled wrong and spell check just hates it? Textbook, sorry. Yes, spell check just hates it. Gastrin, ghrelin, gastrin. Good thing it's multiple choice. Ghrelin, gastrin. Forgot an R. Good. Now, anytime you see the word gastric, that is a stomach word. So if you have a gastric bypass surgery, that means you're shortening your stomach. Good. Ghrelin, the location is the stomach, and that is the enteroendocrine cells. Ooh, tricky. And the action of ghrelin is to stimulate the hypothalamus to increase appetite. Okay, stimulate. Gastrin and ghrelin. Ghrelin. Okay, I can't spell? Come on. Come on, spell check, do your thing. We'll get it later. Spell check hates me. No big deal. We'll get to it later. Now, gastrin is also in the stomach. Enteroendocrine cells, and it is to, right now it just says gastric function. We'll add more detail to it later, because if you look, it produces gastric juices. Whoops, textbook. So, which influences gastric function. We'll talk about it later. Increases appetite. So if you are, the whole idea there is once food comes in, it will turn on your stomach and increase your appetite, so that way you eat more. Good. So that is the stomach facts. Now, how does the body work? Let's look at it. This is a little bit more detail than you need to know, but it's good to realize that when you smell something, you can become hungry. When you hear something regularly, you can become hungry. And part of this shows that when you're hungry, it can also be related to your thoughts and your memories. I just want you to realize that the thought of food will send nervous impulses to your stomach. And then once food is inside your stomach, that stretching will trigger nerve reflexes, which release gastric juices and gastrin. And then once chyme moves into your stomach, it will also when chyme, which is the acidic solution of food and enzymes and hormones, moves into your duodenum, which is the first part of your intestine. It will trigger more nervous impulses, which then will inhibit the gastric secretion. So gastrins is basically the hormone that turns the stomach on and says release more gastric secretions. And then once it gets into, the food gets into your duodenum sends an inhibitor of gastrin, which basically says we're done with the stomach, shut it down. And that's important because you don't want the stomach releasing all these enzymes and acid if there's no food in there to act on. Okay, so that is the stomach. Now, next we're going to look at the intestine, and then we're going to come back to the liver and the pancreas, because although they're very important, if you don't understand the intestine yet, they dump into the intestine. So we'll come back to those. Let's look at the small intestine. Now, the small intestine is divided into 3 parts. The duodenum, and then you go to the jejunum and the ilium. The duodenum is the first 10 inches of the small intestine, which basically is Latin for 12 because it was 12 finger breadths long. So if you were to go like this, it's 12 fingers. Okay. The duodenum is the first part, and that is where the pancreatic juices dump in, and we'll talk a little bit more about that later. So the digestion still continues because you have these pancreatic juices in, but you also have chemical absorption starting to occur. So let's summarize the green box. The duodenum is the first 10 inches or 25 centimeters of the small intestine. It begins at the pyloric valve and ends when the intestine turns abruptly downward. Extra information. It receives chyme from the stomach as well as the pancreatic juices and the bile, which we'll talk about later once we get through the whole rest of the intestine. Okay? More digestive processes occur here than any other part of the small intestine, and those processes occur because of the pancreatic juices and the bile. Even though the bile is not chemical, the bile is a mechanical process. Then it goes to the jejunum, and then the next 8 feet or 2.5 meters is small intestine. Many large folded areas, millions of microscopic projections, and we'll look at that later. Thick muscular blood supply, and this is gives it the red look of the intestine, as we saw in the video in the in part 1. Then you have the ilium, and the ilium is the last 12 feet, last 3 meters, because did you know that your intestines are 9 meters long, which is, or 7 meters long. Anyway, from here to across the room if you're in a room, or 7 meters, I'm not quite 2 meters. So basically, let's say most of you are 1.5 meters. So that's like 5 times up and down if you're to take your guts and stretch it up and down, which I know sounds really gross, but that's kind of cool. In your ileum is where your Peyer's patches are. So now let's look back at the structure of the small intestine. The small intestine is, well, you can tell it's the small intestine because when you look at it, it has these beautiful villi or folds in it. Let's look at the cute little baby and go into a cute little baby's guts.
About an hour later, the stomach squeezes the broken down food out through a tiny hole called the Pyloric Sphincter. The food enters the small intestine, an 11-foot coil of tube where we absorb most of the nutrients. The interior wall of the small intestine is lined with millions of microscopic projections called villi. These increase the surface area of the gut, making it easier to absorb nutrients. First, the pancreas pumps out a juice that neutralizes stomach acid.
Okay.
She can take on...
We'll come back to the actions of breaking down of the stomach or the intestine and the enzymes from the pancreas in the next video. I want to finish looking at the intestinal lining. So when we look at the intestinal lining, again, you have your mucosa, submucosal, muscularis, and scleraris, and you have these circular folds. And the interesting thing about them is, as you saw from the video, it looks like a fuzzy blanket inside because you have all these projections, and they're called villi. One's a villus, a bunch are villi, and they add surface area. So you have all these folds, so that increases the surface in which the nutrients can be absorbed. And I want you to realize inside every villus, you have a very good blood supply. So here's your artery, then you have your vein. But you also have this green line, and if you remember back to the other chapters, anytime you have green, you have lymph. So the green is the lymph. And remember when we talked about lymph, we talked about a lacteal. And a lacteal is a finger-like projection of the lymph, and fat will absorb there. So small intestine, very good surface area due to villi. And here's a new cell too, a goblet cell. So the villi are absorbent, but the goblet cell will produce mucus. So again, you have lots of mucus in your gut, which helps lubricate your food and move it along, and also help protect your gut cells too. Now, sometimes on the villus are cells with microvilli. So to add even more, you have microvillus. And if you remember from way back, you've got your columnar cells, and you have a lot of mitochondria because it takes a lot of energy to move substances in. Okay, let's stop this video here, and actually let's take a few more minutes and just finish the intestine. So we'll come back to digestion, but let's just talk about intestines. Then the large intestine is the last step. And the large intestine, as I says, has the ascending, which goes up, the transverse, which goes across, and the descending, which goes down. Again, you have you have valves or sphincters that control the movement in and out. You also have this interesting line here, which is just connective tissue and muscle, which helps move it along. And then we talked a little bit about sigmoidal colon, and then the rectum are parts of the large intestine. And the large intestine is where water, the main thing absorbed is water. So if your poop, for lack of a better word, goes through your intestines too long, you will become very solid. And this is where the water is removed and it becomes the word feces. Okay, I'm going to stop here because we've talked mainly about the structures in this video, and in the next video we'll continue on with the detailed accessory organs and more discussion about the chemical breakdown and what enzymes are coming from where. So stay tuned.